a class, I already post the assignment in Google Classroom. So the assignment, 4 to 6 members in one group. Okay, but depends on the class size. You can double confirm with your tutor if you can allow to have 7 students in one group. Okay, it depends on your tutor. So for the assignment, there's a 2 tasks. Task 1, all is theory, explanation. So the task 1 is describe the process, encryption, description, and all the point what you need to include is already listed here. First thing, introduction. What you need to include in introduction is already right in here. So it's very clear where you need to include for all the parts. And task 2 is also theory, asked to explain the security issue. The due date is on 2nd September 2025. So you can submit the assignment to your tutor. Any question you can ask me later. Okay, chapter 2. Chapter 2, total 81 slides. All theory. Today is better, everyone sit in front. At least someone is sitting in front. Okay, we start with chapter 2. Okay? If you're sleepy, you can sleep, but make sure you read it before the final exam or midterm test. Today, all is theory. I know boring, but if you listen, there's a bonus mark for you. You can understand it. If you read it yourself, 50% you cannot understand. Okay, today we will focus on the symmetric encryption. You know what is symmetric encryption? Don't know. Have you heard the word symmetric and asymmetric? Yes. So symmetric encryption requires how many keys for the encryption? Okay, for the encryption, there's a 2 types. One is symmetric, one is asymmetric. Symmetric encryption requires 1 key. 1 key is also known as 1 secret key. For the asymmetric encryption, there's a 2 key. One is known as public key. Another one is known as private key. So when I ask you how many keys is required for symmetric encryption, you need to answer once. What does it mean once? Once means that you use the same key for encrypt and decrypt. You know what is encrypt? The file, PDF file. You don't want your friend to read it. You encrypt the PDF file with the password. Let's say you set a password ABC. So when the receiver receives it, you need to use the same password ABC to decrypt to decrypt the file and read the document. This is means by one key. Use the same key or same password for the encryption and decryption. Asymmetric means that two key. Encrypt and decrypt is different key. There's a different algorithm. Some algorithm using the public key for encrypt. Some algorithm use private key to encrypt. You only remember asymmetric two key. One public key, one private key. One key for encryption, one key for decryption. So there's a 5 ingredients. One is original data.
用球衣的，照来说，
Original data. Ori data. Encryption algorithm is the algorithm you use to encrypt the plain text. Later on, I will describe. There's a few algorithms you will study today. For the symmetric encryption, there's a total 3 algorithms. One is known as DES, 3DS, and also AES. You will learn these 3 algorithms. This algorithm is used for the encryption. Secret key is the key used for the encryption. Ciphertext. What is ciphertext? Ciphertext. After you go through the plain text, you go through the process encryption and transform it to the ciphertext. Ciphertext is actually the data that is not understood by the reader. You already convert the data to other things. Okay? This is known as the ciphertext. Decryption algorithm, when receiver receive it, you need to use the algorithm to decrypt it in order to read the data. Okay, to convert from the plain text to ciphertext, there are 2 algorithms here. One is known as substitution, another one is transposition. What is substitution? Yeah, substitute. You can see from here, this is the plain text. Substitute the words with other character. This is the plain text, this is the ciphertext. Substitution is the techniques used to convert from the plain text to ciphertext. The technique used is to convert the word to other character. For example, H is replaced with 5 here. So when the data you send through the internet, the hacker read the data but not understand. This is substitution. Another technique is known as transposition. What is transposition? You can see from here. Rearrange the words. You can see hello Alice has been rearranged to something like this. This is still hello, but the sequence is not same. O at the last place here become the first place here. So transposition is rearrange the words or change the sequence of the words. Substitution, what is substitution? Substitute the words with other character. Remember, there's a 2 techniques to convert from the plain text to ciphertext. First one is substitution, second one is transposition. Substitute, when you heard the word substitute the words with other character. H become 1, E become 2. Substitute the word with other character. Transposition, rearrange the sequence, rearrange the words. H from first place change to second places, change the sequence. So if the question asks you to illustrate, what does it mean illustrate? You can draw out and explain it. You can draw out the diagram, something like this. You can write down the message and then substitute the word you use, number, substitute it. And transposition, you just rearrange the word. Okay? So during the midterm or final, ask you to illustrate, you need to draw out and explain it. So this is the explanation. I'm not going to read out. I already explained for you what is substitution, what is transposition. This is in the word form. You can read and understand it. Okay. Okay. First part. Any question? Change from the plain text to ciphertext. There's a two techniques. Understand? Okay. Okay. The number of key use. So there's a two types. One is symmetric. Another one is asymmetric. Symmetric only use one key. The key sometimes they mention as secret key. Secret key means that one key. Public key means that two key. One is public key, one is private key. So there's a different terms. Sometimes they does not use symmetric. They use secret key. Secret key is also known as one secret key. Symmetric encryption. Asymmetric, two key. One is public key, one is private key. Sometimes they just say that public encryption. So from here you can see symmetric means that the key for encryption and decryption were using the same key. Asymmetric means that they were using the different key. Any question? Second part, symmetric and asymmetric. One key and two keys. First part, convert plain text to ciphertext. There's a two techniques. Substitution, transposition. Second, symmetric, asymmetric. Symmetric, one key, asymmetric, two key. Can remember? Can. Don't say confirm, then midterm you forget everything, huh? Okay, after from plain text to ciphertext, you want to encrypt it. Encrypt it, there's a two techniques. One is block cipher, one is string cipher. After you convert from plain text to ciphertext, you want to encrypt the ciphertext. There's a two techniques. One is block cipher, one is string cipher. Block cipher means that you encrypt the entire block. This is the block size, huh? Block cipher means that you encrypt the entire block in the same size. Another one is string cipher. String cipher means that you did not encrypt the entire block. You divided the block into bit or byte. Do you know what is bit? Okay, you divided the block into bit or byte and encrypt bit by bit or byte by byte at all times. Okay? So can you differentiate between block cipher and string cipher? Block, you encrypt the entire block in the same size. String cipher means that you divided the block into bits or bytes and encrypt the bit or byte at all times. So this is you can read yourself. String cipher means that encrypt the data one bit or one byte at a time. Block cipher encrypt the data in fixed size block. So for the encryption algorithm is classified into block cipher and string cipher. Later on we will study the algorithm in this block cipher. So from here, plain text, the text you can read, you can understand. After that, you will go through the transposition or substitution. After that, you will encrypt with a key, either block cipher or string cipher. Understand? So here you understand the plain text convert to ciphertext. There's a two techniques, substitution, transposition. Then after that, you want to encrypt it with a block cipher or string cipher. Okay, what is cryptanalysis means? It means that you attempt to discover the plain text or key. For example, you get a ciphertext. You want to know what is the actual plain text. What you will do? when you want to know the plain text, you require the password. So how you going to attack? There's a 3 types of attack here. Brute force attack, dictionary attack, and probable words attack. What is brute force attack? Brute force attack means that I try out all the possible passwords. For example, I try out 1 to 1000, all the possibility. I try out all. This is known as the brute force attack. Trying and testing all the possible key. This is known as the brute force attack. Another one is the dictionary attack. Dictionary attack means that you will search for the large number of possibility. It means that you will search for the most common password used by the user. You compile all, then you try out the possible password. So the difference between brute force and dictionary is brute force you try out all possible password. Dictionary attacks you find out the most common password, then you only try out the most common password. You did not try it out all. Another last one is probable words attack. This one is actually a word set in a text. You assume that the text, maybe there's some word that's combined together. You guess it can be the password. For example, the words in the document, you find out this, then the password may be this one. This is the word that you find in the text. Any questions so far? The 3 types of cryptanalysis you study: brute force, dictionary, probable word attack. I don't want to read out all the word by word now. You will see later on. I just explain for you. You go back and read it. So as I explained just now, there's a 3 algorithm for the encryption: DS, 3DS, and AS. All these you require the block size and key size. The key for the encryption. Encryption you need key, but there's a different key size. From here you can see that when the key size is larger, increasing, the time required to decrypt it is also increasing. What does it mean? It means that the larger the key size, it is more secure because you require more times to decrypt it. From the 3 algorithms, there's a 3 algorithm you already today. DS, 3DS, and also AES. So 2 of the algorithms were using this Fustar cipher structure. Okay, 2 of the algorithm will use this Fustar cipher structure. The algorithm is DS and 3DS. We're using this Fustar cipher structure. Okay. This is actually a block encryption. Just now you read about block encryption and string encryption. This DS is actually block encryption. You can see this is the process for you to convert from the plain text to ciphertext using this Fustar cipher structure. Can you see the word iPad? Can? Cannot? You want to make it larger? Can? Can you see the word? Back color background. So I will summarize for you. There's a three algorithm. One is DES, another one is 3DS, and another one is AES. So DES and 3DS were using the Fustar cipher structure. AES will run it parallel. Okay, DS will use 64-bit block size and 56-bit key. What does it mean 64-bit block size is? You can see this is the DS process. When you want to go through the encryption process, you'll go through this one. This is encryption. You require the key. So the DS, the key size is 56-bit key. And also the block size is 64 bits. The block size means that the size for the plain text is only support 64 bits plain text. So in one round, in the Fustar cipher structure, there's a multiple round. In one round, they will go through this process. You want me to explain it or you want to learn it in the practical class? Practical class, huh? Okay, I explain a little bit. This is actually a practical. I open the practical. So you will go through the initial permutation. What does it mean is, you key in the plain text. For example, this is your plain text. You go through the first step is initial permutation. Initial permutation means that rearrange the bits. For example, the bit is 8-bit plain text. You will go through initial permutation. Initial permutation means that this is stand for the bit number 1 to 10. So the outputs I will rearrange. The third value will move to the first place. The fifth will move to the second places. The second will move to the third places. Rearrange, permutation. Okay, rearrange the inputs to get these different outputs. So you can see from here, you can see 0, 1, 1, 1, 0, 0, 1, 0 will change to the second place will move to the first place. 1 become in front, then 0, 1. Follow the formula. The formula will be given. What is initial? What is P10? P10 is input something like this. You will need to come out this output. Okay. You need the key. This red color box is actually the key you key in. So after you key in the key value, you will go through the process. Permutation 10. Rearrange the key. Rearrange it. Then divided into 5 bit and 5 bit. Then left shift. Left shift means that shift 1 bit in front. You see, huh? 1 will shift left, become back here. 0, shift front. Shift front. It will become 0, 0, 0, 1. This you will learn in the practical class. So I roughly go through. So after you get the key one, after you go through this process, P10 is also permutation. This input follow the formula P8. You input, you will get this output. Follow the sequence number. So you'll get this output. After that, you will use this key one to encrypt the plain text. After you go through the process, then you'll get the ciphertext. All this is not covered in the midterm or final. Just explain for you to understand how it's convert from the plain text to ciphertext. I need to explain, if not you know, what is DS? What because I want to study, I don't want to study, I need to memorize. Memorize. For this subject, you need to memorize. And you did not use all the algorithm. I just let you know how the algorithm works, okay? So, you know what is the blocks, what is the key. So from here, you can compare. There's a 3 algorithm. First one is DS, 3DS, and AES. DS using 64-bit block and 56-bit key. As I explained just now, the key size increasing, it is more secure, is it? That's why they come out the second technique, known as 3DS, to solve the limitation of DS. You can see the key size has been increased to 168-bit key size. Okay, 168-bit key size. So, what is 3DS? Okay, DS is also one all this process is known as DS. 3DS means that 3 process. 3 process. 1, 2, 3. 3DS. 3DS. Why increase the number of round? Why increase the number of round? To increase the security. The number of round increasing, it is more secure. You go through multiple process, multiple time the process, it is more secure. So what is the drawback if you increase the number of rounds? Yeah, time. The time required to complete the process is longer. So that's why they come out another algorithm known as AES. Filter cipher structure that involve multiple rounds. DS less round. 3DS is 3 times the round compared to the DS. So the time needed to complete the process much more longer. That's why AES does not using this filter cipher structure anymore. AES using 4 steps. It's run parallelly. What does it mean? AES there's a 4 stage. One is permutation, and then 3 substitution stage. You can see the stage is substitute bytes. Substitute the value with another value. Shift row means that shift 1 bit in front. Do you know what is shift? Shift. For example, your friend from the first place, shift 1 places. So shift to the right. Your friend will shift to the right. Shift. Okay? Mix column and add round key. You know what is XOR function? XOR function, because bit by bit you will go through the XOR function. XOR function is actually when you 0 XOR with 0, the output will be 0. 0 XOR with 1, you will get 1. I just let you know, all this is not come out in the midterm or final. I just let you know what is XOR function. Okay? 1 XOR 0, you will get 1. Yeah. Different value, you will get 1. Same value, you will get 0. This is XOR function. So you can see from here, as I say, 3DS, the time required to complete the process much more longer. That's why they come out this AS. You can see once you key the plain text, all the plain text will convert to the ciphertext parallel. You see all the bit by bit here will run parallelly. So it is much more faster to complete the process. Okay, come back to the slide here. How many algorithms for the encryption you will study in this chapter? 3. DS, 3DS, and AS. Okay. DS and 3DS using the filter cipher structure. How you going to improve the security? Yeah, it's 3 times. So there's a term used here. Okay, for this slide. This slide is also very important when you check the midterm or final, it keep on come out this type of question. How are you going to improve the security in the DS and 3DS? You can use the block size. You know what is block size? The plain text size. So larger the block size means greater the security. Greater the block size, greater the security. Key to encrypt it. The larger the key size means greater security. As I mentioned that when you increase the key size, the time required to decrypt the text will be increasing. So that you increase the key size, you will increase the security. Number of round. 3DS more round or DS more round? Yeah, 3DS more round. When you increase the number of round, you will increase the security. Okay? The algorithm complexity, the greater complexity of the algorithm, the greater difficult for the cryptanalysis. Okay? The round function and the fast software encryption and decryption. When you have the fast software encryption and decryption, you will prevent this hacker have the times to encrypt or decrypt the text. Okay. So this is the terms you need to know. How to increase the security in DS and 3DS? You increase the block size, key size, number of rounds, and also encryption, decryption times required, and also the complexity of the algorithm. Okay? So for midterm and final, it asks you to describe it, don't just write the block size. If you just write the block size, you only maybe can get 1 mark. So you need to explain more, increase the block size for greater security. I know the block size will affect the security, but you need to explain more. How the block size, increase the size of the block, okay? And the key size, increase the key size. So this one you can read. DS is a block cipher, so you will use 64-bit block size and the key size is 56-bit key in length. This one must remember. Key size, block size, all this must remember. Okay? Sometimes I will ask, does AS use 56-bit key size? Justify your answer. You need to give me yes or no. And you need to give me the correct answer. Okay? The key size, the block size, all this you need to remember. How to increase, how to improve the security, improve the key size, block size, all this you need to remember. So the following slide, this one is not important. You don't need to memorize all the image here. This is the process for the DS, as I explained in the practical just now. You'll go through the step by step in the practical class. You no need to remember, you just understand it. Maybe it's useful in the future. So you just see. So you can see DS, there's a multiple round here. You will go through the round 16 and so on to convert the plain text to the ciphertext. So as I say, the number of rounds increasing, it will increase the security. And also the key size used to create a key for the encryption. Just now you see the key, how to go through the process and use the key for the encryption. You can see every round they will produce the ciphertext. From the plain text, round 1 produce the ciphertext. The ciphertext will go through the second round, third round, and so on. So every round, this is the process. This is the process as I explained just now. The key come in, go through the permutation, slash, shift, and so on. So this is known as the filter cipher structure. Which algorithm using this structure? DS and 3DS, yes. So you can see from here the disadvantages of DS is actually the key length is only 56 bits. It is not large enough. And then the block size is only 64-bit block size. So the fixed block size can be problematic when the encryption large amount of data. When your plain text is larger than this 64-bit size, you're not able to encrypt it. You're not able to convert the text to the ciphertext. So this is the limitation for this DS. And triple DS, you can see the key length has been increased to 168 bits. And that's involve a 3 process compared to the 3DS. You can see from here there's a 1, 2, 3, 3DS. And the key length is 168-bit key length. And the limitation is the longer times needed to complete this process. So they propose another algorithm known as AES. AES, the block size is 128 bits. It's much more larger compared to the DS and 3DS. And the key length support is 128, 192, and 256 bits. And it is not using this filter cipher structure. It will run the entire data in parallel using the technique substitution and permutation. Okay. So AES using the technique substitution and permutation and run parallelly. So the process much more faster compared to the 3DS. So this is the process in the AES: substitution bytes, shift row, mix column, add round key. This one is also important. You need to explain the steps, the stage in the AES. Substitution bytes means that you perform byte by byte, substitutes the words with another character. Okay. Shift row means that you shift the row by row. Shift left or shift right. You can see from here, shift the bit to the left or right. Okay. And this mix column, mix all the bits to one. Mix all the bits to one. Mix. Add round key means that add all the value here with the value here. So you will get the output. So from here you can see the stage for the AES: substitute bytes, shift row, mix column, and add round key. Any problem? Okay, for the algorithm, more things for you to memorize: the key size, the block size, how to improve the security, which one using the filter cipher structure. Okay, the next part is key distribution. So how you distribute a secret key to your friend? For example, you encrypt a file. You want to let your friend know the password. How you let your friend know? You don't want email, because once you key in the password in the email, there may be hacker to hack it to read the password. How are you going to distribute the password? Here, option 1 means that you walk to your friend's house and let your friend know the password. Physically deliver it to the box. Or there's a third party know the password and go and meet A and B and let A and B know the password. This is the way how you share the secret key with your friend. In the next chapter, you're going to study another algorithm, how to share the secret key with your friend. Here, just a basic to let you know how you share the secret key to your friend. And also, the next one is you can encrypt it. What does it mean? Means that previously you have one password, you have one key. You encrypt the new key with the old key. And then send it to your friend. Your friend will decrypt it with the old key and read the new key. So your friend know the new password. You use the old password, encrypt the new password. Or using the third party. Third party, as you can see from this diagram, host A or you can use this third party. Third party is also known as key distribution center. Key distribution center means that they will share the secret key with you. Okay, it's a third party, share the secret key with you. When Alice as a host want to connect with the bot, what Alice do is, Alice will ask the session key from the KDC. They need the session key for the connection. So KDC will send the secret key to the Alice and bot. And the session key is actually encrypted with a master key. Means that the key is secure because the key is encrypted with a master key. Alice and Bob have the master key, decrypt it and get the key, and then only Alice can connect with the Bob. This is key distribution center. So the function of key distribution center is actually the third party who manage the session key, who manage the key. When you want the key to connect it, to encrypt it, to decrypt the password, you need to get from the third party. This third party is known as KDC, Key Distribution Center. This one not important, other symmetric box cipher you don't need to study. Okay, come to last part. So far okay? Yes, this chapter is boring compared to chapter 1. Chapter 1 is much more faster. After this, there's a more algorithm for you to study. It's more boring. But no choice. When I mention it's important, then you just read it and memorize it. Okay, 5 more minutes. Okay, what is packet switching network? Encryption across a packet switching network. When you're sending the data, what you can encrypt in the network part. The first part is known as the link. You can encrypt the link. Link means what? The connection between one devices with another devices. Means that the cable encrypt the link, the connection. Once you sending your data, you want to make sure the data is secure. So you encrypt it, the link. Second, this link encryption is a lot of encryption devices. You can see there's a lot of encryption here. 1, 2, 3, 4, 5, 6, 7. There's a total 7 encryption here. High level of security and decrypt each packet at every switches. What does it mean? Means that the link, when you encrypt it, means what? You will encrypt the data. The data, the network packet, if you read it, if you know, the packet is actually divided into header and also the data. This header is also consists of the source IP address and destination IP address. When you sending this data, reach these devices, you want to know the destination, right? So when you encrypt the entire things, these switches does not know where to send the packets. So what the switches do is, the switches will decrypt this thing, will decrypt the data and read the destination. After read the destination, then only it will encrypt it and send it to the next destination. So every time reach the switches will decrypt the things to read the destination IP address, only to send to the next places. So this is not secure. Why? Because when you reach the switches, you need to decrypt it. If the hacker is there, hack the switches, what will happen? The hacker can read the data. So it is not secure. Okay? Because the switches need to decrypt it and read the destination. Only know where to send the data. This is link encryption. Link encryption is encrypt the link, all the connection. What is end-to-end encryption? One end and another end. You can see from here one end beginning and the destination here. End-to-end encryption, only one end and another end. For this technique, header is not encrypted. What does it mean? The header, just now the link to link encryption, the header is encrypted and the data is also encrypted. For this end-to-end encryption, only the data part is encrypted. The header is not encrypted. So when the data only need to encrypt at the beginning, and once the receiver receives it, it will decrypt it and read the data. This is end-to-end encryption. Data is encrypted, the source encrypt and the receiver will decrypt it. Okay. So for this high security, both link and end-to-end encryption are needed. Okay. So you can combine both these techniques together. So you encrypt the data and header, and another one you just encrypt the data part. You encrypt 2 times. So the data is actually secure using this both link and end-to-end encryption. So this is the disadvantages for this packet switching network. When reach all the switches, you need to decrypt it to reach the destination IP. Okay? So thank you. Still remember or not? Okay, so go back to revision, block cipher, string cipher, substitution, composition, DS, 3DS, and AS. Okay, thank you, class.